Hi guys, I welcome you all to my YouTube channel. So in this video I am going to discuss one important topic, that is shear force and bending moment diagram. Okay, so this is one question. Okay, so before going to solve, let me explain the sign convention for this problem. Okay, so not for this problem actually, for any shear force and bending moment diagram you can follow this rule of sign convention. Okay, so if you see from left hand side of a beam, then upward shear force will be considered as positive. Now, so this entire beam system is in equilibrium. So in order to be in equilibrium, there must be some reaction. Okay, this is RA reaction and this is your RB reaction. Okay, so upward shear force is positive from left hand side. So if you see from this left hand side, so this RA is acting upward, so it will be positive. Okay, and this 2 kN is acting downward, so it will be taken as negative in the shear force diagram, and similarly it will be negative and it will be positive. Okay, now so this was the sign convention. Similarly you can see for couple or moment. Suppose this is a beam, this is a simply supported beam, and there is a moment M and there is a moment of 2M. Okay, so if you see from this left hand side, then this M moment is acting clockwise direction, so it will be taken as positive in bending moment diagram, and this 2M is acting counterclockwise when you are seeing from left hand side, so this will be taken as negative. Okay, so now let me find the reactions at the ends of this beam. So if you see, if you draw one imaginary line, these both the sides are looking similar, right? So this RA equal to RB will be how much? 2 kilonewton. Why 2 kilonewton? Because total vertical downward force is 2 plus 2, 4 kilonewton. So in order not to fail this beam, total vertical upward force will be again 2 kilonewton, right? So both RA and RB will be 2 kilonewton. This is 2 kilonewton and this is 2 kilonewton. Okay, now let me draw the shear force diagram. This is your neutral axis. Okay, this is your neutral axis, and this reaction is acting upward. See here, upward shear force is positive. Now this shear force will be drawn as, this is 2 kilonewton. Okay, so this is 2 kilonewton. From here to here there is no shear force. From here to here there is no shear force. So up to this point, this is 2 kilonewton will be there. Now this 2 kilonewton is acting downward, so it will be negative. So this is 2 kilonewton. 2 minus 2, it will be 0. 0 means it will come to the neutral axis. So this is okay. Now from here to here again there is no shear force, so it will be 0, 0, 0, 0, 0. Up to this point there is 2 kilonewton acting downward. Here there is no shear force. 2 kilonewton upward, then again because of this 2 kilonewton downward, the shear force becomes 0. So 0, 0, 0, 0, 0 minus 2, because 2 kilonewton acting downward, right? So this is 2 kilonewton coming negative in negative direction. Again from here to here there is no shear force, so it will go like this, like this, like this. Again this RB is acting upward. From left side it is acting upward, so it will be positive. So this is minus 2 kilonewton, right? This is minus 2 kilonewton and this is plus 2 kilonewton acting upward. So this will go to the neutral axis like this. So this is 2 kilonewton. So this is the shear force diagram for this entire beam system. Okay, now let me draw the bending moment diagram. For bending moment diagram, let me draw the neutral axis. Okay, so this is the neutral axis. Just projection of this beam. This is the projection of this beam and this is the projection. Okay, so for rectangular shear force, the bending moment diagram will be linear. So this distance is 1 meter. Again this is 1 meter. And again this is 1 meter. So if you consider one imaginary section here, okay, and this distance is x, suppose from this imaginary axis to this support, this is x. So because of this reaction Ra, this beam is going to bend in clockwise direction, right? This Ra is going upward, so this will fail like this in clockwise direction. See, from left hand side, clockwise couple is positive, right? So the bending moment diagram will be positive. So this is positive and this is negative section, right? And this is the neutral axis. So I will draw this bending moment in positive part. Okay, so this force into distance 1 meter into 2, this is your up to this, as it is rectangular, this is constant shear force, right? This is constant shear force from here to here, this is constant shear force. So bending moment will be linear. So this is your linear. Okay, so after going from here to here, there is no shear force. There is no shear force. So bending moment will be constant. This will be not linear. Okay, this is linear because there is shear force. There is constant shear force. So there will be linear bending moment. And there is no shear force. So there is constant bending moment. So this bending moment will be continued till this point, right? After going to this point, this bending moment is 2 kilonewton into 1 meter, that is 2 kilonewton meter. As it is in negative direction, as it is in the negative part of this neutral axis, so this will go down and this will be again your linear. Okay, so this is 2 kilonewton meter, force into distance, this is 2 kilonewton meter. Again this will be continued to 2 kilonewton meter and finally it is 0. It is 0. Remember, bending moment at the ends, at the fixed points will always be 0. See here, it will be always 0. And whenever there is a shear force, there will be sharp increase or decrease in the shear force diagram. See here, this is a reaction inside, this is a constant, this is a point reaction, right? So there is sharp increase in shear force. And there is no shear force, so this is your constant line. And again there is a point load, so there is sharp decrease in shear force diagram. And there is no shear force, so it is 0 0 0. And again because of this point load, there is sharp decrease in shear force diagram, like that. Okay, so this is your shear force diagram and this is your bending moment diagram. This is a simple problem. I will explain one complex problem in the next video. Okay, so thank you.